Hi everyone, thank you for coming along to my talk this afternoon. As you can kind of see from the first slide, the format of my talk is probably a little bit different to talks you've seen before. The reason for that is, I suppose what I'm doing is I'm telling the story of what the work I've been doing for the past 6 or 7 years. So I wanted it to look a little bit different. So what we've actually done is we've done this talk in the format of a comic book, the whole talk. So the whole talk is in this kind of format. And what I actually have is small printed versions of the talk as well. So if anyone wants a copy of that, if you put your hand up now, you'll be given a copy. And then I'll get on with this talk. So what I'm going to be talking about is, as you've seen in the schedule, what I've called the Realex Payments Application Security Story. And it really is the story of how the company I work for and me in my job at Realex went from no application security in the business to where we are today. And you'll get to hear where we are today near the end of this talk. Well, the reason I did this talk was towards the back end of last year, I saw 2 really good application security talks. So one from the security guys at Etsy and one from the security guys at Twitter. And they showed a really good level of automation. So they showed that they were really brilliant at automating application security and so on. And my immediate thought when I saw that was, that's brilliant, but how does a company get from nothing to where those companies are right now? Okay, and I said that to a couple of people, and their response was, well, if you think someone should talk about that, then why don't you go and talk about that? So I kind of gave myself work to do by doing that, but that's what I'm here to talk about today. So I joined the company I work for, Realex Payments, in 2006. So it's actually almost exactly 7 years ago now. And when I joined Realex, I was working in an operations security role initially. So, managing firewalls, security configuration of routers and switches, that kind of work. But then, at the time, the company had about 15 members of staff. And to give you some idea of how much we've grown, we had about 15 in total. When I joined the company, we've hired about 125 in the last year. So the company is significantly different. But as we started to grow, we realized that the most important part of our payment processing platform was the code. So we paid a lot of attention to the security, of our hardware and our servers and our firewalls and so on. But all of the bits of the platform that did the real work in terms of handling sensitive data, handling data from the web and so on, that was code that we had written in-house and still do today. So we realized that actually what we needed to start looking at was application security. So the business said, well, David, you know how to write code and you know about security, so you're no longer our operations security person anymore, you're going to be application security. So thrown in at the deep end, I didn't really know too much about application security at the time, but I was given 2 high-level objectives by the business. The first one was to review every bit of code that we had written for the previous 7 years. And I'll touch on that in a second. That wasn't the most enjoyable part of my job over the past 6 or 7 years. And then secondly, ensure that everything we did in the development department was compliant with the relevant PCI requirements. And I know PCI and boo, no one likes PCI, but that was one of the 2 objectives I was given at the time. So the rest of this talk is going to, explain how we started from nothing and built that up over the past 6 years. So when I was tasked with doing that initial review, I kind of felt like the guy on the screen after the review had finished, and I'll explain why in a second. But on that first slide, I said that we hadn't done any application security up until that point, up until this point. And that's not, completely true, because our developers had been on OS Top 10 training course. But any of you who've been on those kind of training courses probably realize that what that means is someone showed our developers how to exploit the vulnerabilities in WebGoat and sent them back to the office saying they know how to write secure code. And I'll come back to that point a little bit later on in the story, because that's something I tried to tackle within our company and the industry a few years into this story. So because the business thought the developers knew how to write secure code after that course, the developers themselves were responsible for application security. It didn't work out too well, as you can imagine. But basically what we had was that the developers had a checklist item, so when they did their peer review, they ticked this box and said, yeah, it's free from the OS top 10 vulnerabilities. Didn't really work too well. So the first thing that I did was take that first objective and figure out, well, okay, I need to review all of this legacy code. But even at that point, the company had been going for 7 years, and we were still fairly large in terms of the big customers we had, the transactions we processed. So there was still a lot of code. So we had to take a risk-based approach initially. There was no point in me starting that review of the legacy code on some buried away back-end web service, service. Where I needed to start was our XML web service, which is the very core part of our payment processing engine, and I'll come back to that again later in the story because we've rewritten that since, and the web applications that our merchants and customers use. So what that actually meant was in the first 6 months of my job, I reviewed about 250,000 lines of code, and it wasn't nice code, I suppose. You think of brand new applications and they're nice to follow, nice to read, but I'm talking about web applications that were written in classic ASP. I'm talking about our XML web service, which was almost exclusively written in Perl, that had no, development standard applied to it over the years. So some of the parts of the code, we had like 1 or 2 Perl files with 10 or 15,000 lines of code in them. Okay, so it wasn't really an enjoyable first 6 months in application security. But we started to find bugs. As you can imagine, I found security bugs in that code, because if you've been writing code for 8 years with zero attention to application security, you're going to have security problems. So what we needed to then look at was, okay, we'll start projects and work to fix all of the legacy code, but what do we do to make sure that new code doesn't introduce new security problems? Now, any application security person in this room will probably give you, a very similar first answer to that. And that answer is normally something like, go and integrate security into your software development lifecycle. Okay, but if you've ever worked in a startup company and you try and go to integrate things into a software development lifecycle, you might look a little bit like the woman on the screen there, because that was kind of my reaction when I realized we didn't really have a software development lifecycle to integrate security into. So I suppose I had 2 choices at that time. I could walk away and tell the business, yeah, when you've got this process, I'll come back and we'll do security, which wasn't really an option. So what I did was I sat down with the people who were responsible for, changing our code, because they must have been following some kind of process. They must have been taking requirements from somewhere, and they must have been following some kind of process to turn that into something that was released into production. Okay. So what we did is we sat down and we wrote that out, and we basically ended up with what was a waterfall methodology, a very basic one, but it was ultimately a waterfall methodology that they were following. So we sat down, we defined that, but the next part of the next step, I suppose, was probably one of the most important things looking back that I've ever done. So one of the things I spoke about actually last time I was here speaking at Hack in Paris 2 years ago was this idea of the KISS principle. Keep it simple, stupid. Okay? Don't overcomplicate things. Keep things really simple. Now, if we would have done something or tried to take something like the Microsoft SDL and apply the whole of that to this really small startup company, we would have got nowhere. Okay? Because you're trying to go from nothing to lots of things in the SDLC. So what we did is we sat down and we wrote out this SDLC, and it was really simple. Literally, our first SDLC was me opening up a Visio diagram and drawing out like 5 or 6 squares and a little bit of text underneath each one, and then that was our SDLC. I know when I look back, I kind of cringe a little bit thinking about that. That's the first thing we used, but the point was the business at that point said, okay, we buy into this idea of a defined process, and we'll include security in that process. Okay, so there's lots of things you might want to do from a security point of view, and those are things that we did eventually add into the process, but we had to start simple. Because if we'd have said from straight away from day one, if we'd have said we want developer training, we want risk assessments, threat modeling, security code reviews, security testing, and a few other things on top of that, the business would have probably laughed at us and said, this application security work sounds like it's a bit more effort and a bit more investment than we're actually willing to do. So we said, okay, the minimum that I'd like to have is training for our developers, security code review, and security testing before anything gets to release to production. So security testing was something we needed to look at. And it became pretty obvious that, there are lots of different choices when you want to automate security testing. But when it came to web application automation, and this was touched on yesterday in the Burp Suite talk, this is probably the tool that you want to be using for that. For our web applications, at least. We do something slightly different for the web services. But, we're talking here like 5 years ago. So after I'd initially gone and done a bit of research, it was obvious Burp Suite was what we needed to use for our testing. And when I started to use that in my security testing, I found that developers and QA were coming up to me and saying, that's really cool. How did you find that problem? Or how did how were you able to run thousands or tens of thousands of tests against our web application? Because we'd like to do that as well. So what we found was that, well, at least with our developers, that if a clean security review and testing is important or vital for them to go live, if they want to be proactive about that, which our developers did, we decided that we would give them the tools to be proactive. So we actually bought a license, and this is still the case today, a professional license for Burp Suite for all developers, all QA, and all of our security staff. Now, it isn't mandatory for any of those other roles outside of security to use Burp Suite, and we find that some teams use it a lot and some don't, but we give them that option there to be proactive for a fairly cheap price, to be honest, for Burp Suite. So as we progressed, we had this SDLC, we were doing these security code reviews, doing these security tests at the end of the process, and that itself started to highlight problems with our SDLC, because we started to find issues after QA, when we were doing our reviews and testing, which when we looked at them, we could have easily found much earlier in the process. So like a real simple example would be something like cryptography. So a developer might write in the design document he's going to use DES for encryption. Now, if we find that problem at the design phase, he literally has to hit backspace, change one character, and that problem is avoided. If you are finding the same problem after QA, it might still be backspace and change a character, but that then probably has to go back through QA and security code review and security testing. So we wanted a way of identifying problems and threats much earlier in the SDLC. So again, after a little bit of research, it became fairly obvious to me that threat modeling was what we needed to do. Because I didn't want to have something, ultimately the goal was to have security review the design document. But I didn't want us to add a deliverable in the SDLC that says, get security to review the design document. I wanted something more repeatable than that, something that we knew that whoever did that check, they applied the same process to that, if that makes sense. So we started to use the Microsoft threat modeling approach, which is what I assume pretty much everyone does when they start doing threat modeling. So we bought the Microsoft threat modeling book, we used the Microsoft threat modeling tool, and basically applied it exactly as Microsoft say in the book. But we found over time there were things in the Microsoft process that didn't give us value for money, for the time that we were putting into it. So off the top of my head, things like use cases and the threat trees, whilst they're good and they have a value, they weren't giving us value, if that makes sense. So we've modified that process over the years, so it's not exactly the same as the Microsoft approach now, but it's a threat modeling approach that works for us. But the biggest change, and the biggest, one of my favorite things that we've done over the years when it comes to threat modeling and application security in general, is moving threat modeling away from being almost a security team exercise to something that involves a lot more people. And the way that we did that is we started playing a card game with our developers. And not just developers, with project managers, with QA staff, with a lot of different roles. And the way that we did that is we actually adopted the Microsoft Elevation of Privileges card game. So this was a card deck that Microsoft produced that basically Without going into all the details, you have different suits of threats, so very similar to a normal card deck, and then you have, 8, 1, 2, 3, etc. in the card deck, and each one of those has a threat on them. Okay, so you shuffle the cards, deal out cards to everyone who's playing the game, and then everyone who's playing the game has to try and explain why the threat on their card applies to the application or the development that you're looking at. Now, when I read that, I was skeptical. I thought, I can't really see what benefit we're going to get from playing that game. But I thought, we'll try it anyway. Microsoft make all of the cards and the graphics and everything you need to play the game available for free on their website. So all we did is we got all of those, got a deck of them printed really cheaply through our marketing team, and we started playing the game. Now, the amazing thing to me was, from the very first game, is people's attitude to win is something that might surprise you when you first play this game, because what we see is the developer who might have written the design document and needs to write the bulk of the code, he wants to win the game so much, he's trying so hard to find problems with his homework. And he's saying, yeah, I might have written this in the design document, but this problem could exist still. So they try incredibly hard to find problems in their own developments. So we're sitting there as a security team thinking, this is fantastic. And over time, what we've actually seen is, by playing this game with the developers, we find twice as many threats as we did without playing this card game. Because in a way, the card game acts like a checklist. And again, if any of you were here from my talk 2 years ago at Hack in Paris, I talked a lot about checklists and how they can be useful to security. But in a way, this game is the same, because you will always look at and analyze every single threat every single time you do a threat model. Okay? There's lots of kind of science around why people get so sucked into playing these games and why they work. I won't go into detail here, but it's been incredibly effective for us. So, in the early days, after we put that first SDLC together, we kind of looked at that, and I suppose looking back, the answer was obvious. We had this Visio diagram with some squares drawn on it. We looked at that and said, well, none of us have ever done this before, so how do we know if we've done a good job? Okay? And we didn't. I suppose looking back, it was kind of obvious it wasn't great. But what we decided to do was bring in an external auditor. So this wasn't an audit looking at PCI or ISO compliance or any of those kind of things. What the auditor was doing was taking the process that we had defined, point out any problems in that process, and then look at 1 or 2 projects that we had put through that process and tell us whether we had followed that, if that makes sense. So, it was not a pleasant experience, I suppose, the first time we did that audit, because the auditor pointed out, I suppose, again looking back, it's kind of obvious, lots of problems. So, in 2008, they had 30 pages of problems with that SDLC. And you might look at that and think, well, compared to 2009, I didn't do too much work in that year, but that isn't true, and I'll explain why. In 2008, the auditor came in and pointed out lots of fundamental problems with the SDLC. So even things like, okay, we had a design phase and we said that we'd have a design document, but we didn't even have a template for designs. So everyone was going off writing designs in different ways. We said we did security code reviews, but we didn't even produce evidence for that. The only time we had evidence is if we raised bugs and they were in the bug tracking system. So again, some real fundamental problems with the process. So what we did is we kind of stepped back and said, okay, we know some of the things work okay for us, but when we look at that auditor's report, we probably should just start again, build something brand new. So we kind of took that Visio diagram, pretended it never existed, and then based on that auditor's report, what we had seen in projects over the previous year following that SDLC, we then put that towards producing something new. Okay, so we went away and we put I suppose what I would call our first proper SDLC together. So the auditor came back in 2009, and although they came up with a lot of suggested improvements still, they were more kind of fine, I suppose, process improvements. So instead of, you don't even have a template for design documents, it was a case of, when you go from the design phase to development, you don't have things like entry and exit criteria defined. Okay, so making sure now that we have a process that's more detailed and more refined. But one of the things the auditor pointed out to me at this point was that I should be collecting data about application security, collecting metrics about what we do. Now at the time, I'll be honest, I thought this sounds like a waste of my time. But you'll see later in this story, 2 or 3 years later after this auditor's suggestion, it turns out that was one of the most important things we ever did. Okay, so I'll come on to that later on. So then in 2010, we brought the auditor back again. But at this point, we'd refined the process. We'd looked at the 2 years' worth of suggestions and so on from the auditor. And what we'd also done at this point was build our first agile methodology with security built in throughout it. Now, I'll come back to that agile and security a little bit later on. But you can see that the auditor was struggling to find problems then. So not only were they looking at the waterfall methodology, they were looking at agile as well. The agile one was pretty solid because we'd had 2 or 3 years worth of lessons that we'd learned from waterfall that we could bring across into that agile process. And then in 2011, they came back and they could only give us 2 pages of suggestions. Now, I don't know if any of you out there who don't have English as your first language, whether that word nitpicking at the bottom there makes any sense to you at all. But basically what that means is someone is trying really hard to find problems where there are no problems to be found. Okay, and that was the word that the auditor used. They said, if you don't change anything after this, you don't need to bring us back. Okay, so you can see that bringing that external auditor in allowed us to make quite rapid progress with our SDLC and make that mature very quickly. Now, we didn't bring them back last year, but because we've hired so many people over the past 12 to 18 months, we will be bringing them back in again later this year, just to make sure that the processes haven't really changed that much, but we want to make sure that all of the new staff are still applying those processes properly. So as we started to progress through the years, we were doing that security awareness training to begin with, and a lot of it was based on OS Top 10. Okay, and that's where a lot of people probably still start nowadays, but that's where pretty much everyone started their developer training back in 2008. But as time went on, I started to realize that, well, actually, that's not what I want our developers to learn about. And what I mean by that is, did I want our developers to learn about and understand a small set of vulnerabilities, or did I want them to understand how to write secure code? Okay, and really the difference there, and I've given full conference talks on this, so you can get all of the information about what I'm going to tell you next on the Security Ninja website. We've published it all for free. But basically, we developed something called the Principles of Secure Development, which is still a list of items, but rather than talking about SQL injection and cross-site scripting and so on, we actually talk about the things that a developer needs to do right. So we talk about input validation, output encoding, error handling, secure communications, and so on. So that's how developers are taught. But to reinforce that at all times, that's the language that we use as a security team throughout the SDLC. So our design document doesn't talk, in terms of vulnerabilities, it talks about that in those principles. So the developer has to define how they're going to do input validation correctly in that application. Our security code reviews, we use a checklist that has something like 70 items on it. And every one of those items is mapped to one of these principles. So when we raise a bug for that, the developer can see, well, okay, that was answered no, and it's output encoding. Or that was answered no, and it's logging and auditing. So I'm maybe logging credit card information or whatever it might be. And the same as when we raise a bug. We might mention that, lack of input validation could lead to SQL injection, but we don't go off on a tangent about what SQL injection is. We focus on which principle has been violated and what changes the developer needs to make to ensure that application implements that principle successfully. And as I said, all of the information on that is on the Security Ninja website. So if you want presentations and documents and standards to use that principles approach yourself, it's all up on the website. So one of the other things we started to do early on, and this is something the company supports anyway, but it's sharing the knowledge that we have. So you've seen already, I've talked about, but I'm here doing a conference talk, so that's one example. But even the fact that we developed this principles of secure development approach and we've released that for free. We've developed open source application security tools that started off as a way for us to be better internally, and we've released those externally. Again, one of them I talked about 2 years ago here at Hack in Paris, and we've just released a static analysis plugin for Eclipse that I'll touch on a tiny bit later on in this talk, and something else that we'll be releasing shortly as well. So there's lots of things there that we've done about sharing our security knowledge externally. But one of my favorite ones probably over the years has been the fact that we're a financial services company. We're nothing to do with the security industry really. And we made it onto the front page of Slashdot for a positive reason, for security content that we'd written on our security blog. Now normally the only time payment processors end up on the front page of Slashdot is when they've been compromised and someone has stolen all their data. So that's something that I was proud of. So as we started to grow as a company, the company structure internally started to change. So I suppose initially a development department was, I suppose, what you'd expect it to be. One big development department, and every developer kind of worked on every product or service. What we changed to is this idea of small product-focused teams. And what I mean by that is we've got teams of like 4 or 5 people, and they're responsible for the management, owning, development of a certain set of products. So external web applications, for example, that's one small team. Any change to those web applications happens through this one team. And then we have the same for internal applications, our XML web services, and so on. But what that means from a security point of view is something really good. Because before, you had to try and teach every developer about every problem that could occur in every application and service that we work on. Now, depending on what you work on, the security issues are significantly different. So you could be working on, a back-end web service that connects directly to a bank over private connectivity using a proprietary protocol, or the next day you could be working on the XML web service that's web-facing that literally anyone can send requests to. There's a difference in what the developers need to understand and how they need to write that code. So where we've been lucky, in a way, is that allows us to give the developers extremely targeted developer education. So we give them generic overview of everything they need to know, but then we'll sit down with them and say, look, we talked about doing canonicalization and input validation in the generic sense, but here's exactly how you apply that in the application that you work on, right the way down to the code level. So we'll go to them and say, well, if it's the modern web applications that we use, we'll use the Enterprise Security API from OWASP. So I can go to them and say, look, if you call this method in this way, your canonicalization and input validation is taken care of. Okay? So it's allowed us to tell them exactly what we want them to know rather than trying to tell them about everything. So again, when I look back, we kind of had 3 different phases of automation. So we had that very early one where I talked about Burp Suite. And then after that second audit where the auditor had told me to start collecting metrics and so on, I kind of realized that I didn't want to be doing a lot of that work manually. So they were talking about collecting metrics, creating audit trails, creating reports, and all those kind of things. And I thought, well, I could probably write software that'll do that for me. Okay, so out of that audit, I wrote a piece of software that ultimately got released as an open source tool, and it's called Agnitio. I released that, I think, for the first time in like late 2010, I think, the first public release. And it's been downloaded about 15,000 times since then. And basically, it's the tool that we use for all of our security code reviews internally. So the checklist that I talked about before with these 70 questions on, they're all within this application. And then by completing the checklist for an application or service, it does all of the things that I don't like doing. So I don't know if you have this product outside of the UK and Ireland, but we have a product called Mr. Muscle, which is a cleaning product. And his slogan is that he loves the jobs that you hate. And I suppose in a way, this tool was the Mr. Muscle for our security code reviews because it did all of the work that I hate doing, that need to be needs to be done, collecting metrics, doing audit trails, creating reports and so on. I just didn't like doing it myself. So this software took care of that for us. But what it was also doing, it was giving us a database that we could refer to at any time to get loads of different information about our security code reviews. And I'll come back to why that was important a little bit later on. But one of the other things we did at this point is we realized that, and probably everyone knows it, but we realized that QA were getting a lot more time, a lot more money, and a lot better tools than we had to test our releases. So we went along and we decided, well, we'll make friends with QA and we'll figure out, well, okay, what tools do they have that we could probably use as well? So we found that they had this tool from IBM called Green Hat, which is expensive, far more expensive than I could, get bought from a security point of view. And basically what that does is it allows them to do automated testing of our XML web service. So what it does is it submits an XML request, it'll submit valid and invalid data, and then you wait and see whether the service reacts as you expect it to. Now, does that sound like something that security could use? Well, it did to us. So what we did is, shamelessly, we copied and pasted the tests that they had created, gave them a load of security tests and said, can you run those every night as well? So they added that into their nightly testing. So that service for the past few years has had about 400 or 500 security tests run against it in an automated manner every single night. And because we went and made friends with QA and basically copied their work, we were able to use a tool that the business had confidence in without spending a penny to buy licenses, to do vendor selection, to implement it, or even to manage it. We don't even manage the tool. QA takes care of that for us. So if you've got a QA department and you want to make application security better, they've probably got some things that are going to be useful. So one of the other things we did as this company started to grow is the owner of Realex Payments founded a new payments company. And I'm not going to go into the details of what they do, but it's different to Realex. There's no credit cards involved, there's no PCI or anything like that. But the problem was, and I was kind of sweating, I suppose, a little bit like the lady on the screen there at this point, was that they came along and said, well, okay, all of our developers are coming from outside of the business, we're hiring new developers. That waterfall approach you've been using, too slow, we're not going to use that, you need to be agile. And you need to have at least the same level of security as you have for Realex. So I sat there wondering, okay, everything that we've put together for the past couple of years in Realex with developers that we've trained and educated and we've built the process to support application security, can we move that and drop it into another company and hope that it works seamlessly? Well, I suppose the answers were kind of yes and no. We did bring everything across. So we do have an agile methodology that includes risk assessments, threat modeling, security code reviews, security testing, and where necessary, external pen tests. But it wasn't, completely smooth because, as anyone will tell you, if someone says they're going to do agile development, that actually means they're probably going to do it in one of about 1,000 ways. So you need to actually go out and figure out how are they actually going to do that. And now when you look back, that's not too different to what I had to do in the very early phases of the story, right, where I had to figure out how Realex were actually writing software. So what we found was that worked. We could bring security into this agile methodology, bring brand new developers in off the street, put them through our education process, and we could still do application security at least as well as we were doing in Realex, okay? But what we've also seen is probably some unexpected benefits from that. And what we've seen is, because Carapay allowed us for the first time to use our security approach in something that was brand new, because before that we were just fixing up legacy code and adding to legacy code in Realex. This was the first time we built something completely new following our security processes. We learned a lot from that, and more specifically, this improves security in Realex a couple of years down the line when we went through a phase of building everything brand new, and I'll touch on that again in a minute. Because what we did with Carapay was get them to implement things like the Enterprise Security API from OWASP, to implement cross-site request forgery controls, for example. And then when we came along to build brand new web applications in Realex, we found that we could just copy and paste, almost literally copy and paste what we'd put together for Carapay and apply it to Realex. So that means that now, a few years down the line, we've got two different companies, two different sets of developers who use the same security libraries, the same controls, same education approach, and so on, which makes our security training, reviews, and testing significantly easy. Because of that success with Carapace, Realex said, well, okay, we want this secure, agile approach. So towards the end of 2011, we moved Realex across that as well, because we'd done the hard work of putting it in place in the first place for Carapace, learned what did and didn't work, and then we applied that into Realex. So everyone's been following this secure, agile methodology for about 18 months now. So one of the other things we've been doing in Realex, starting around 2011, was basically rebuilding everything. I talked about earlier on, we're about 3 years back in the story from where we are at this point, how we had these Perl files with 10 or 15,000 lines of code in them, classic ASP, web applications. We quickly realized that as we were growing fast, we couldn't scale. We couldn't implement the kind of features that our merchants wanted, that we wanted to implement. So we decided, well, okay, we just need to start actually building everything again. So we started with the very core part of our service. So I'm going to give you a bit more detail on this in a second, but this was the first time in Realex that we could build something completely brand new with security in it from day one. And not just something brand new, this was the most critical service for the business. If that service is down or unavailable, then there's like 15,000 companies that can't process card payments. So it's pretty important to us. But what I've said on this slide is, by building security into this from day one, I've said that we've seen the expected benefits from doing that. And what I mean is, any security person that talks about building security in from day one and all those kind of things, will tell you that if you do that, you should end up with fewer security bugs and so on. And that's what we've seen. So everyone who's worked on this service and does work on this service was hired after all of this application security stuff started. And they came in with almost no security knowledge. So everything that they've learned from our training approach. So this XML web service, it processes over 20 billion euro in payments every year. And I think that's actually closer to 25 billion euro at this point for 15,000 merchants. So that was initially Perl, and we were trying to build a Java replacement and move everyone across. So since we created the first proof of concept version of that, we've done 270 security code reviews, covering about 200,000 lines of code. Now, we've only found 19 security bugs in those 270 reviews. Now, your initial reaction might be, well, David, you might not be very good at application security, or your team isn't good at finding bugs. But to guard against that, we have pen tests quite regular against this. We've even hired external companies to come in and review the code as well at various points. So we found 19 security bugs in those 270 releases. And actually, to dig into that a little bit more, 11 of those 19 bugs were found in the first two kind of proof of concept releases. So what that actually means is in the following 268 reviews, we've only found 8 security bugs. And when you dig into that a little bit deeper, those 8 bugs were found across 5 different reviews. So ultimately what that means is we've done 270 reviews of that, and 263 of them passed first time. Okay, so that when I say we've seen the expected benefits of doing all these things in the SDLC and training developers and so on, this is what I mean by that. So as we were continuing to grow, and Carapace was growing and Realex was growing, and we got more and more developers, that meant we were producing more and more code. But this is where the things the auditor told me at the end of 2009 suddenly started to make sense. Because the auditor was telling me, collect all this information about your security code reviews, when you do them, how much code, etc., etc. And as I said earlier on, I thought that was probably a waste of time back then. But when I started to realize that we were doing so many releases and producing so much code, I probably couldn't review it all properly. I had to take a step back and figure out, well, how do I get the business to give me more application security resources? But when I thought about it, I had nearly 3 years worth of data that I could go back, run SQL queries against, and give the business all kinds of views of that data. And what I kind of figured out was that at that time, I knew more about anyone else, more than anyone else in the business about how much code we released, how many bugs we had, which teams produced the most code, which teams needed a bit more security training because they had more bugs than others. So I was able to go to the business and say, well, okay, we have this limit of about 1,500 lines of code a day that we think a human can review properly in a day. Based on the reviews that we're doing now, we're going way above that, which means the quality of the reviews are decreasing. And then when we looked at Carapay and said, well, this is how much code and how often they're producing it in their agile methodology, when we moved to that from a Realex point of view, this is what that would mean. And what that actually meant was that I could sit down with them and I could say, look, in 2011, I personally completed 150 security code reviews, covering 246,000 lines of code. So I looked at all of the data we had, and I looked at what Carapay were doing, and we made some estimates. And I said, because everyone's going to be on Agile in 2012, I was estimating we do about 3 times the amount of reviews, so around about 450, and covering about 300,000 lines of code. And when we broke that down, we started to realize that I couldn't do all that by myself. And if I tried to, there was going to be lots of work that just wasn't going to get done, lots of important things. So we went to the business, and the business said, well, yep, there's obviously a case for hiring another application security resource because you've got all of this great data to back up your request. What I thought was important was to go back to the business at the end of last year and explain to them how 2012 actually mapped to my estimates. So what we found was that I said I'd do 450 reviews, we did 499, and I said that we'd do about 300,000 lines of code, and we did 295. Okay, now to give you an idea of where we are from an agile point of view now, in the first 2 months of 2013, we did more security code reviews than we did in the whole of 2011 following waterfall. And we would do, on average, about 50 or 60 reviews a month, but what you find is the scope is significantly smaller than the reviews we would do under waterfall. So we're talking very small reviews just quite often. Okay, so the kind of the current or the latest phase of automation we're looking at and working on, again, relied on that data that I started collecting years ago. Because what this data allowed me to do was figure out, well, how can I help our developers more? And you can go out and you can buy static analysis tools, you can buy web scanners and so on, but because we had 3.5 years worth of data, I could go back and look at that and figure out where exactly our developers struggled. And when I went and looked at that and looked at all of the bugs we raised, we figured out that almost all of the problems that our developers had were either input validation, output encoding, or in exception handling. So we started work on tools in-house to help our developers reduce or remove those problems from their code. So the first thing we started to work on was a plugin for Eclipse. Okay, so a colleague of mine called Dermot started working on this. It was actually the first job I gave him when he joined the company, so throw him in at the deep end. I went in to write a real-time static analysis plugin for Eclipse. Okay, so not the easiest job that I've ever given anyone. So he came in and he looked at this and he looked at the psychology behind this. And basically, you'll get better results if you tell someone about a problem as soon as they make that mistake rather than waiting for months down the line. I suppose it kind of makes sense when you think of it. So what we've done is we've developed this plugin that analyzes the developer's code as they write their code. And if they introduce a security bug, they're told about it immediately. Just in the same way as, if they had made a syntax error, we use the same alerting system that's in Eclipse and everything, so it looks the same to the developers. And we tell them there and then that they've just made a security mistake, okay? So they understand, literally as they've typed that bit of code, what that will mean if they don't remove that. So we've released that as an open source tool and it's being actively developed. So I think the website is espplugin.com, but if you just search for ESP security plugin, you'll find that. Or go on the Security Ninja website and search for ESP, you'll find all the information there. So one of the other things that we found was that our developers made a lot of output encoding mistakes. Not because they didn't understand output encoding, because most of the time they got it right, but we'd find, and we use JSP files a lot, you'd find that in JSPs they'd have like 1 or 2 places where they'd just forgotten to do output encoding. So that would cause them to fail a security review. And we thought there's got to be a smarter way of doing this. So we wrote a Python script that every night runs through their project directory, scans through every JSP, and looks for places in those files where they've potentially missed outputting coding. It creates a HTML report, emails the developer a link to it, they go in and review the findings, and if they say it's a false positive, basically a hash is created of that specific bit of code, the line, and so on, so they're not bothered with that again, and they're only left with issues that they need to work on. We're still fine-tuning that a bit, so it's not being released yet, but we will be open sourcing that as well in probably a month or two's time. But what we found is that the small group of developers who use the Eclipse plugin and the output encoding tool have completely eliminated the kind of bugs that we wanted to eliminate. Okay, so we'll find out whether that works for all developers when we push that to all the developers in the company, but the early signs are encouraging at least. So this is the last chapter in the story, right up to date. This is what we're working on right now, and this is native mobile app development, which is why a couple of the talks this week have given me a few interesting ideas. But what we found was that when you look at security or application security at that kind of principles level, rather than at the vulnerabilities, you'll find that when you look at the vulnerabilities in web apps, web services, and then mobile apps, you don't really need to change the way that you teach developers. Storing something insecurely is the same whether you're storing it in your database server on the back end or whether you're storing it in a SQLite database on the phone. So what we found actually, this is how I feel I can prove that everything we've done over the past few years has been successful, is that senior developers that had been hired, everyone had been hired in this period of application security at Realex. So everything they knew, we had taught them. And they sat down, they wrote the design documents and the architecture documents for the mobile app and the back-end web services. And when it came for security review, I asked for almost 0 changes. So what that meant was, because of everything the developers had learned and been through over the previous years, if I wouldn't have been there and they would have built their application service as per the design that they had written, they would have had something that was very secure. So to me, I can look back over those 4 or 5 years of this story and say that, yeah, we made mistakes, but ultimately it's been successful. But I think what's always important to do is look back and point out that the parts in that story where we weren't maybe so successful, or things that I would do differently if I was going to do this all again from day one. Okay? So the first thing I would do is start collecting these security metrics and application security data from day one, because it took me 2 years and an auditor before I started collecting that information. And then what we've seen a few years down the line is that data has allowed me to prove I need more security resources and has allowed me to produce tools that actually help the developers with the specific problems they are having in our business. The thing that makes me, I suppose, sad a little bit about this data and the fact that I didn't have it from day one is I can't stand here and tell you which security tasks or work makes the biggest changes in the early phases of your application security story. Is it developer training? Is it threat modeling? Is it code reviews? I have no data to prove which ones make the biggest difference. Now, to me, I think it's a combination of probably threat modeling, security code reviews, and security testing, because you're covering the early parts of the SDLC and the latter parts, but I don't have the data to back that up. Okay. The other thing I would say is if you have that data, make sure you share it, because I found all kinds of people in the business who find that data useful that I wouldn't have thought about. So, our team leads, for example, take data from me on a monthly and a quarterly basis so that they can give their developers more focused and more, I suppose, realistic feedback when they do their reviews. We report data from our database to the management team every single month. So the management team gets to see application security data, mainly because it's really easy for us to produce and give to them. So one of the other things that probably could have happened earlier, if you remember right the way back at the start of this talk, we did our first formal SDLC kind of after those first 6 months had happened, after I did that review of the legacy code To be honest, they should have happened at the same time. We could have started building an SDLC at the same time as we started those reviews. But I jumped down to the last bubble at the bottom here with that question, because it's the question I had when I wrote this slide. That I got the business to agree to implement their first SDLC with security built into it and so on, I think largely because of all of the problems we found when we looked at all the legacy code. If I would have tried to get them to create a formal SDLC with reviews and testing and so on in from day one, would it have been as successful? Again, I don't know. I can't go back and find out the answer. The next one is, I suppose, more about focusing on what developers need rather than what security people want. And what I mean by that, and I'll kind of hurry up because I'm running out of time and I've got a couple more slides, is ultimately sit with your developers when you give them a security requirement and see what they struggle with. So if you tell them they need to do canonicalization, that's fine. Sit down with them and watch them try and implement that. And you'll quickly find out that what the developers want and what they need is for you to be a bit more specific. So now we go to developers and say, yeah, you need to do canonicalization, but to do that in your application or service, you need to call this method, and then that's taken care of. Okay, so it's only slightly different, but it makes a huge difference to how the developers go about writing secure code. This one, I'll quickly skip over. This was talking about creation of Ignition and collecting that data, that I would have done that earlier because it's driven some smart decisions later in the story. And then the last slide, is a collection of things I would do differently if I was going to do it again. The first thing is that elevation of privileges card game that I mentioned earlier on. I do that from day one if I was building this again now, because it's been so fantastic in terms of giving us better threat models and finding more security issues that it's worth buying or worth paying a printer to print those cards for you. I'd share data with the business earlier because we started collecting that data in about 2009. We didn't really use it for anything or share it with the business till about 2011. So maybe we missed some opportunities in those 2 years. I'm not sure. I'd ban the use of Word and Excel for storing anything that you're going to find useful, because before we had this tool for our reviews and our review data went into a database, it was in a spreadsheet. So I can very easily query about 3 years worth of data, but if I want the full picture of our application security history, I've got to go dig into Excel documents and Word documents and so on. And then the last one is to make friends with marketing and QA. I suppose QA is kind of obvious. I touched on that a little bit before about, using their tools and maybe just copy and pasting their work, which is ultimately what we did. But the other one is the marketing department. What we realized is, obviously, they're the people with the skills and the knowledge about selling things. And ultimately, what I always think the biggest obstacle for security is being able to sell security to the business. Okay, and sell to the business something which often costs money. If you're putting all these things into the SDLC, you're probably going to slow it down a bit. So go and speak with marketing and understand how they sell things that people might not necessarily want to buy, but they still end up buying it anyway because marketing have marketed things very smartly. So go and make friends with those people and learn what makes them good, I suppose. So that's it from me today. So if you have any questions, feel free to ask. The slides are online, so slideshare.net/security ninja, and you'll get the slides there. I'm not sure if there are any of the comic books left, but there's a few, yeah. So if you still want one of those, you can get one of those. But if you have any questions, feel free to ask. No questions? That's always an easy end to a talk. Thank you very much.